copy the session link, whatever I have sent you in your WhatsApp groups or broadcast or whatever it is. Copy that session link and keep it as your WhatsApp status. I know that each and every student knows how to keep a WhatsApp status. We keep so much of other status. Some are relevant, some are probably irrelevant, but still we keep it. But I personally believe that whatever the session which we are taking today is very relevant for so many students. Kindly share it, sir. Kindly keep it as your WhatsApp status. My sincere request for each of the 26 people who are watching this class. Today's session is on a very important topic, mixtures. Today's session is on mixtures. We have already discussed some of the very good questions on averages. I think I took averages close to around 1 month before, if I am not wrong. Some 3 weeks before or 4 weeks before, I took averages, covering from basic level to intermediate level to some of the advanced level questions also. The topic is usually averages, mixtures and allegations. So averages we have already taken. Mixtures is what we are going to take in today's session. We will see when to take allegations. We will see it in our upcoming classes. We will see it in our upcoming classes when to take allegations. Chalo sir, shall we start the class? Shall we start the class? Kindly comment. Shall we start the class? Before itself, I am telling you, I will teach you the basics of mixtures in my problems itself. In my problems itself, I will teach you the basics of mixtures. Do not worry about the basic part. I am sure that I will make you understand how to solve these questions very easily. Do not worry about that part. Now please see here, sir. Today we are going to discuss a very important topic called as mixtures. Extremely important for so many competitive examinations. We will see how beautifully we can solve our problems. We will understand the basics of mixtures also by problem solving, so that we will come to know what need to be taken care of to solve a mixture based questions. Now everyone listen to this very carefully, sir. Everyone listen to this very carefully. Now I will start with my first question of today's class. First let me read the question. Your question is, how many liters of water needs to be added to 30 liters of 3:1 milk and water solution so that the mixture has milk and water in the ratio 2:3? Let us understand the question once again. How many liters of water needs to be added? That means there is a vessel. I need to add some liters of water into the vessel. I need to add some liters of water into the vessel. How much is what they are asking you in the question? How many liters of water needs to be added to 30 liters of? That means initial volume is given as 30 liters. Initial volume is given as 30 liters. 30 liters of 3:1 milk and water solution. Initial ratio of milk and water, it is given as 3:1. So that the mixture has milk and water in the ratio 2:3. Final ratio of milk and water is nothing but 2:3. Again I am explaining you the question in a different way. Your question is, I have initially 30 liters of mixture. Mixture is nothing but a combination of both milk and water. Both milk and water together is called as mixture, or together is called as solution. So initially 30 liters of mixture is present inside the vessel. Now initial ratio of milk and water is given as 3:1, but I don't want the ratio of milk and water to be equal to 3:1. I want it to be 2:3 finally. To convert 3:1 ratio milk and water for 2:3 ratio milk and water, I need to add some water. How much water needs to be added so that initial ratio of 3:1 will finally become 2:3 ratio for a initial volume of 30 liters. Now listen to this very carefully, sir. The key point used in this kind of problems is, what is the key point that I will be using? The key point that I will be using in this kind of problems is, always work with the parameter, always work with the parameter which is unaffected, always work with the parameter which is unaffected. Everyone first listen to this carefully. Always work with the parameter which is unaffected. Now what is the meaning of this statement? That means there is one parameter which is affected, there is another parameter which is unaffected. You should work with the parameter which is unaffected. That means I say that C1 V1 will be equal to C2 V2, where C1 and C2 are initial and final concentrations. Initial and final concentrations. V1 and V2 are initial and final volumes, right? V1 and V2 are initial and final volumes. Always work with the parameter which is unaffected. Now I am adding water inside the vessel. I am adding water into the vessel. If I add water, water quantity will get affected because I am adding water into the vessel. If I add water, water will get affected. What is not affected? Milk is not affected. The meaning of milk is not affected means, how much ever milk was present earlier before I added water, finally also the same quantity of milk will be present, because I am not adding any extra milk into the vessel. I am adding water into the vessel. That means the parameter which is action. Take the initial ratio. Initial ratio is 3:1. The meaning of 3:1 is, out of total 3 plus 1, out of total 4 units, 3 units belongs to milk. Sir, why are you taking milk parameter? Because milk is the parameter which is unaffected. V1 2 liters belongs to milk. Again, why am I taking milk? Because milk is the parameter which is unaffected. V2 is nothing but the full. Finally it becomes 30 plus W. Finally it becomes 30 plus W. If I cross multiply and simplify, there is only one unknown variable present in the question. If I cross multiply and simplify, I will get the answer for W as 26.25 liters. And I am sure that you know how to cross multiply and simplify, because this is something which is taught in our school days. I believe that the first problem is very clear. Do not worry about it. This problem, whatever the methodology which we have used in our first problem, we have used a methodology of algebra, because we are using variable W and we are creating an equation and we are cross multiplying, simplifying, shifting here and there, and then getting the value of that unknown variable W. This is a variable equation methodology and we are not interested with this method. We will very soon shift to a different methodology which does not require any equation to be formed. I hope the first problem is clear. Now listen to the second problem, sir. Please see the second problem. There is a reason behind taking all these questions. You will understand when I keep taking the problems very clearly. You will understand the flow of the class. Now your second question is, 68 liters of milk was added. That means there is a vessel. I am adding 68 liters of milk into the vessel. In the previous question, this parameter was asked as how many liters of water was added. In this question, that parameter value is given in the question. 68 liters of milk was added to 3:7 milk to water solution. That means in Final ratio of milk and water, it is nothing but 7:5. What is the volume of the original solution? That means they are asking you the initial volume. I will call the initial volume as capital V. That capital V value is what we need to find. Now, listen to this carefully, sir. Same logic I'll implement once again. Always work with the parameter which is unaffected. What is not affected in this question? I am adding milk into the vessel. If I add milk, water quantity will not get affected. Milk will get affected. Water will not get affected. So I will work with water in this question. C1 V1 is in this question. V2 is nothing but final volume. Initially there was V liters inside the vessel. It is there on left hand side and right hand side. Shift that V value to one of the sides. Any one of the sides. Cross multiply here and there, shift it. Finally you will get the value of V for this particular question as 100 liters. You will get the value of V for this particular question as 100 liters. That shift second question of this class where I am using this variable methodology. This is my method 1. Method 1 is good to solve. Definitely make sure that you are using variables, you are creating an equation and you are trying to get the answer from that equation. Now we are not interested with this method 1. Now see here, method 2. Method 2. Everyone listen to this carefully, sir. Method 2. Same question I am writing again. I am adding 68 liters of milk. 68 liters of milk is added inside the vessel. Initial volume I don't know. That is what we are finding. Initial ratio of milk and water. It is given in the question as 3:7. 3:7 is the initial ratio of milk and water. Final ratio of milk and water, it is nothing but 7:5. Right? Final ratio of milk and water is 7:5. Now see here. Can I say that I am adding milk parameter inside the vessel. If I add milk inside the vessel, milk will get changed. Milk will get changed. Water will not be affected. That means, what is the meaning of water will not be affected? Water will not be affected means, how much ever water is present initially, same amount of water should be present finally also. That means, how much ever water is present initially, same amount of water should be present finally also. But the ratio says, initially 7 liters of water is present. Finally 5 liters of water is present. They both should be actually same. But they both are not same in this case. I believe that you are able to understand the logic. Actually they both should be same. Because water is not affected, actually 7 and 5 should be same, but they are not same. Make it as same. How will you make 7 and 5 as the same number? It is nothing but the LCM. LCM multiply by 7. That means 3 into 5 is 15. 7 into 5 is 35. 7 into 7 is 49. 5 into 7 is 35. Now if you observe carefully, water in both the parameters, initial and final concentrations, water is the same value 35. Water is not affected. Now if you observe carefully, initially, finally 49 liters of milk is present. That means how much extra milk I added to make it 49. 15 is becoming 49. How much extra milk I added? That means according to the ratio, I am adding 34 liters of milk. According to ratio, I am adding 34 liters of milk. According to the question, it is given as I am adding 68 liters of milk. 34 liters is becoming 68 liters. Multiply by 2. 34 into 2 is 68. Your question is 50 liters. According to the question, they are asking you how much. This 50 also multiply by 2. 50 into 2 is nothing but 100. Answer for this question is 100 liters by using method 2, which is the same answer what you got in method 1 also by using variable methodology. I hope the idea is very clear, sir. As I proceed with more and more questions, I believe that it will be very, very comfortable for you. Please keep on listening to all the problems. There is a flow which is connecting from problem to problem to problem, and you will understand that flow very easily as I proceed with more and more questions. Now, you might get a doubt. Sir, 7 and 5, they both should be same. You might get a doubt. 7 and 5, they both should be same, but they are not same. So we made it as same in this question. What if already those values are given same in the question? Then it is even more easy, right? I don't even have to multiply with any other number. For example, see this question. 66 liters of water was added. That means there is a vessel. I am adding 66 liters of water inside the vessel to 5:1 milk to water solution. So initial ratio is given as 5:1 milk and water. So the ratio of milk and water in the resultant solution is 5:3. Final ratio of milk and water, it is nothing but 5:3. What is the volume of the original solution? Initial volume is what they are asking in the question, which I will call it as V. This is exactly similar to my previous question. There is no difference. But in this question, I am adding water inside the vessel. If I add water inside the vessel, milk parameter will not get affected. Water will get affected. Milk is not getting affected. So what I can say is, because milk is not affected, how much ever milk is present initially, same quantity of milk should also be present finally. That means according to ratio, initially milk is 5 liters. According to ratio, finally milk is also 5 liters. They both are becoming same, and that is what the concept also says. That means in my previous question they both were not same. I made it as same, but in this question they both are same already, so I don't need to make it same once again. It is already same. That means, can I say that according to ratio, initially it was 1 liter of water, finally it is 3 liters of water. 1 liter water became 3 liter water. That means I added extra 2 liters of water according to ratio. But according to question, I am adding 66 liters of water extra. 2 is becoming 66. Multiply by 33. Find the initial volume is the question. According to the ratio, initial volume is 5 plus 1, which is 6 liters. According to ratio, it is 6 liters. According to question, they are asking you how much. 6 also multiply by 33. 6 into 33 is 198 liters. If you observe carefully, I am not using any equation to solve this kind of questions, which is my method 2. I hope the idea is very, very clear for you, sir. Slowly, I will scale up the level of difficulty. Some good questions I am going to discuss in today's class. Shruti, is the sound not clear, ma? Is the audio not clear? Let me remove and replug it once again, whether it is clear or not. Let me remove and replug it once again. Please check for the audio right now. I think audio should be clear right now. Is the audio clear now? Shruti, please comment. Please see the next question. your question is, two alloys containing copper and iron in the ratio 5:8 and 5:3 are melted in equal quantities. Very, very important statement or word in this question is equal quantities. They are melted in equal quantities. That means there are two alloys, alloy 1 and alloy 2, and they are saying that copper and iron, they are in the ratio in alloy 1 as 5:8, in alloy 2 it is 5:3, and they are saying that they are melted in equal quantity. What is the ratio of iron and copper in the resultant alloy? What is the ratio of iron and copper in the resultant alloy? Now see here, what is that they are saying in this question? These two alloys of copper and iron of 5:8 and 5:3, they are melted in equal quantities, it seems. What is the meaning of equal quantities? The meaning of equal quantities means in alloy 1 there is 5 units of copper, there are 8 units of iron. So totally alloy 1 has 5 units plus 8 units, which is 13 units. Alloy 2 has 5 units of copper and 3 units of iron. Totally alloy 2 is having 5 plus 3, 8 units. Question says alloy 1 and alloy 2, they should be melted in equal quantities. But 13 and 8, are they in equal quantities? No, 13 and 8 are not equal. Equal quantity means it should be 1:1 ratio finally after they are mixed or melted. 13 and 8, they are not equal. But question says they should be made equal. So I want to make these two numbers 13 and 8 as equal numbers. That means I need to make them as same number, means I should take LCM. LCM of 13 and 8 is 104. Multiply 13 with 8. Multiply 8 with 13. That means multiply 5 and 8 with 8. Multiply 5 and 3 with 13. So if I rephrase my diagram, alloy 1 and alloy 2, copper and iron, 5 and 8 multiplied with new multiplying factor 8. 5 into 8 40, 8 into 8 64. 40 plus 64 is 104. 5 into 13 is 65. 3 into 13 is 39. 65 plus 39 is also 104. So if you observe carefully, 104 is to 104, it is nothing but equal quantity, 1:1. They are asking you the ratio of iron and copper in the resultant alloy. Copper is nothing but 40 plus 65, which is 105. Iron is 64 plus 39, which is 103. Iron is to copper is what they require. Answer is 103 is to 105. Answer is 103 is to 105. I hope the idea is very, very clear for you, sir. Suppose, for example, if I reverse it, what is this question telling you about? In this question, they are telling you about 13 is to 8 is the ratio, but you should make the 13 is to 8 ratio as equal ratio 1:1. That means this question is telling you about the question they are not given in equal quantities, but you should make it equal. Please see the next question. It is the reverse. The second question, the next question says two solutions containing milk and water in the ratio 2:3 and 3:2 are mixed in the ratio 1:4. That means there are two solutions, solution 1 and solution 2. Two solutions has milk and water in the ratio 2:3 and 3:2. If you observe carefully right now, 2:3 means 2 units of milk and 3 units of water. Totally 5 liters in solution 1. Totally 3 plus 2, 5 liters in solution 2. Now 5:5 is nothing but equal quantity. It is there in equal quantity in this question, but they don't want you to keep it in equal quantity. They want you to mix it in the ratio of 1:4. I believe that you are able to understand the logic. In the previous question, the ratios were not equal, but you should make it equal. In this question, the ratios are equal, but you should make it unequal. In what ratio they want you to do it, sir? In the ratio of 1:4. Multiply that first one by 1, second one by 4. That means solution 1, solution 2. If I rephrase the diagram, 2 is to 3 multiplied with 1 is again 2 is to 3. 3 is to 2 multiplied with 4. 3 into 4 is 12. 2 into 4 is 8. So if you check, 2 plus 3 is 5. 12 plus 8 is 20. 5 is to 20 is nothing but 1 is to 4, which they are asking you in the question. Find the final ratio of milk and water in the resultant mixture. Milk finally is 2 plus 12, 14. Water finally is 3 plus 8, 11. Answer is 14 is to 11. Simple way of problem solving. Let us not make it complicated. Easily we will solve the questions. Please see the next question. Your next question is, two vessels contain milk and water in the ratio 9 is to 7 and 5 is to 11. That means there are two vessels. Milk and water is given in the ratio 9 is to 7 and 5 is to 11. That means they are saying that first vessel has milk and water totally how much you have according to ratio 9 plus 7 is 16 units. Second vessel has milk and water as 5 and 11. 5 plus 11 is also 16. Now read the next statement. If the both vessels are mixed in the ratio 1 is to 1. If both the vessels are mixed in the ratio 1 is to 1, find the ratio of milk and water in the new mixture. Now, both the vessels, they should be mixed in the ratio 1 is to 1. 16 is to 16. It is already there in the ratio 1 is to 1. 16 is to 16 is nothing but equal to 1 is to 1. Because they are already there in the ratio 1 is to 1, you don't need to calculate any other things, but you need to calculate the final ratio of milk and water. Milk finally is 9 plus 5 is 14. 7 plus 11 is 18. 14 is to 18 can be further simplified as 7 is to 9. In the question, they are saying in the question that it should be mixed in the ratio 1 is to 1, but they are already in the ratio 1 is to 1. What if they are not in the ratio 1 is to 1? That I have already solved before, or I am going to again solve in my next problem. Please see this question, sir. Few questions are only for your understanding. I am repeating same varieties of questions so that you will understand it better and so that you will solve it. Now see here. Listen. Two vessels contain milk and water in the ratio 7 is to 8 and 13 is to 5. Milk and water are there in the ratio 7 is to 8 and 13 is to 5. So 7 plus 8 is 15. 13 plus 5 is 18. Initially 15 liters of mixture is present in vessel 1. 18 liters of mixture is present in vessel 2. That is the first statement. If both vessels are mixed in the ratio 1 is to 1, both vessels need to be mixed in the ratio 1 is to 1. But 15 is to 18. 15 is to 18 is not equal to 1 is to 1. But you should make it equal to 1 is to 1. 1 is to 1 is nothing but both should be same numbers. 15 and 18. Which number can I make it 15 and 18 as same number? LCM of 15 and 18. LCM of 15 and 18. It is nothing but 90. So 15 into 6 is 90. These two values also multiply by 6. 18 into 5 is 90. These two values also multiply by 5. Now my new values becomes 6 into 7 is 42. 6 into 8 is 48. 42 plus 48 is 90 for your information. 5 into 13 is 65. 5 into 5 is 25. 65 plus 25 is also 90. Observe carefully, 90 is to 90 is nothing but 1 is to 1, which they are asking you in the question. Find the ratio of milk and water in new mixture. In the new mixture, milk is 42 plus 65, which is nothing but 107. 48 plus 25, which is nothing but 73. This is my answer. we will discuss some initial basic levels. Slowly we will scale up the level. Please see this question. Another similar kind of questions for your better understanding. A and B are two alloys of tin and copper prepared by mixing metals in proportions 13:11 and 5:7 respectively. That means there are two alloys A and B, tin and copper. It is given in the ratio as 13:11 for alloy A and 5:7 for alloy B, right? This is what the first statement says. So 13 plus 11 totally 24 units is present in alloy A. 5 plus 7 totally 12 units is present in alloy B. This is what I can understand. Next statement. If equal quantities of two alloys melted to form a third alloy C, I am trying to form a third alloy C in this case by making it as equal quantities. That means 24 and 12, they are not equal, but the question says please make it as equal. What is the number which can be made as the same number from both 24 and 12? It is nothing but LCM of 24 and 12. LCM of 24 and 12 is 24. So 24 should become 24. Multiply by 1. These two values also multiply by 1. 12 should become 24. Multiply by 2. These two also multiply by 2. If I rewrite it, so A and B alloys 1 into 13:11 is 13:11. 2 into 5 is 10. 2 into 7 is 14. Now they are trying to form a new mixture, new alloy C. This alloy C is nothing but combination of alloy A and alloy B. Find the proportion of tin and copper in alloy C. So tin is nothing but 13 plus 10. It is 23. Copper is nothing but 11 plus 14. It is 25. Similar kind of questions what we have solved in our previous questions. Please see this question, sir. Please see this question. Your question is, two vessels contain milk water in the ratio 5:9 and 7:11. That means there are two vessels. Milk and water is given in the ratio of, it is given in the ratio of 5:9, right? It is given as 5:9, and the second one it is given as 7:11, right? Second one is given as 7:11. So 5 plus 9 is 14. 7 plus 11 is 18, right? This is what we can understand from the first statement. If both vessels are mixed in the ratio 4:3, that means both the vessels should be mixed in the ratio 4:3. Now, whatever the mixture that you are doing, this mixture should be in the ratio how much? It should be in the ratio 4:3. They are not saying you to keep that mixture in the ratio 1:1 like our previous problems. They are not asking you to keep it in equal ratios, or they are not asking you to keep it in 1:1 ratio. They want the ratio to be 4:3. Find the ratio of milk and water in the new mixture. Now, forget about 4:3, sir. Forget about 4:3. Let us first make it as 1:1. Let us first make it as 1:1. 1:1 means they both should be equal numbers, which we know how to make it from our previous problem. 14 and 18 should be made as the same number. The LCM of 14 and 18 is 126. 14 into 9 is 126. 18 into 7 is 126. That means now I multiplied 9 and 7, so that 14 and 18 both became the same number, which is 126. Now when I multiplied by 9 and 7, it became 1:1 ratio, or it became equal ratio. But the ratio should not be in equal ratio. It should be in the ratio of 4:3. Now make that as 4:3. Multiply this by 4. multiply this by 3. I believe that you are able to understand the logic. I hope that you are able to understand it so easily, sir. That means, can I say that instead of multiplying directly by 9 into 4 and 7 into 3, which I will find it little difficult to do it, first make it as equal values, first make it as equal ratio, then whatever the mixture they are asking, multiply by that value. Now, even more to simplify our problem to little more easier extent, this is 3 into 1. This is 3 into 3. That means, in simple language, this value of 14 is multiplied with 3 into 4, 12, or this both values are multiplied with 12. Similarly, this value of 18 is multiplied with 7 into 1, or these both values are multiplied with 7. If I rewrite it, 12 into 5 is 60. 12 into 9 is 108. If you check 60 plus 108 is 168. 7 into 7 is 49. 7 into 11 is 77. 49 plus 77 is 126. Check it out if you want. 168 is to 126 will definitely be in the ratio of 4 is to 3. If you want, you can check it out. Final ratio of milk and water is 60 plus 49. It is 109. 108 plus 77. It is 185. This should be my final answer. Whenever they want you to keep it in some ratio other than the equal ratio, first make it as equal ratio and then convert it to whatever the ratio they are asking. Simple. Now, before moving on to the next problem, listen carefully here, sir. Before moving on to the next problem, I am sure that you have attended my fraction to percentages conversions. Even if you have not attended, you should definitely know all those fraction to percentages conversions. In that, one of the fraction to percentage which I did not discuss is 46.66 percentage. How to convert 46.66 percentage to fractional value? 46.66 can be written as 30 percentage plus 16.66 or 67, whatever it is, 16.67 percentage. 30 percentage is 3 by 10. 16.66 percentage I taught you in my fraction to percentages as 1 by 6. If I take the LCM, 10 and 6 LCM is 30. It is 30. So it is 10 into 3, 6 into 5. 3 into 3, 9. 5 into 1, 5. So it is 9 plus 5, 14. 14 is nothing but 14 by 30 is nothing but 7 by 15. So whenever some values which are given in the question which we have not discussed, you can derive it whenever you require, because some other values we have discussed as 16.66 as 1 by 6 and something else, right? I hope the idea is clear. Similarly, we also know that 55.55 percentage we have discussed in our fraction to percentages as question is a multiple of 11, so denominator should be 9. Question is 5 times of 11, so numerator should be 5. All these things we have already discussed. All these things we have already discussed earlier. I believe that the idea is clear. Now see here. Please see my next question, sir. Please see this question. Your question is, let us first read the question, understand it. 2 vessels contain mixture of milk and water. That means there are 2 vessels. There are 2 vessels containing mixture of milk and water. Mixture 1 and mixture 2. Milk and water ratio I need to give it. Now let us check it out. What is that ratio? In first mixture, milk is 46.66 percentage. That means, can I say that in the mixture 1, in the first mixture they are saying that milk is 46.66 percentage. 46.66 percentage I told you sometime before as it is 7 by 15. What is the meaning of 7 by 15? The meaning of 7 by 15 is denominator always represents the total value. Total mixture is 15 liters. Total mixture is 15 liters. Out of total 15, 7 liters belongs to milk parameter. That means 7 liter is milk. Total is 15. That means water should be remaining 8. 7 plus 8 only is total 15, right? So total value is 15 means out of 15, 7 belongs to milk. So 7:8 should be the ratio of milk and water. And in the second mixture, water is 55.55 percentage. Mixture 2 they are giving it as water value, they are giving it as 55.55, which is 5 by 9. The meaning of 5 by 9 is denominator represents total. Total mixture is 9 liters. Total mixture is 9 liters. Out of that, water will represent 5 liters. If water is 5 liters and total is 9 liters, milk should be how much? Milk should be remaining 4 liters. So we understood the meaning, or we understood how to find the ratio of milk and water in both the mixtures. Now read the next statement. If both vessels are mixed in the ratio 7:6, this mixture 1 and mixture 2, they both are mixed, and you will form another mixture called as mixture 3. That mixture 3 ratio should be 7:6. Find the ratio of milk and water in the new mixture. Now see here, sir. Can I say that the ratio, whatever they are mixing, that mixing ratio should be in the ratio of 7:6. Now I already taught you in my previous question that whenever they are asking you some other ratio other than the equal ratio, first make it equal ratio. That means 15 and 9 are the values which are there. They are not equal. First make 15 and 9 equal. The LCM of 15 and 9 is 45. So 15 into 3 is 45. 9 into 5 is 45. Now they are in equal ratio. I believe it is clear. 15 into 3 45, 9 into 5 is 45. 45 is to 45 is equal ratio. Now they are in equal ratio, but they don't want you to make it in equal ratio. They want it in the ratio of 7:6. Multiply by 7, multiply second value by 6. Now I can further simplify this ratio, because this ratio is, this is 3:6 ratio. 3 into 1, 3 into 2. Further can be simplified. That means this 15 should be multiplied with 7, or in other words, these two values should be multiplied with 7. This 9 should be multiplied with 5 times of 2, which is 10, or these two values should be multiplied with 10. If I rewrite the diagram, milk and water is 7 into 7 is 49, 7 into 8 is 56, 10 into 4 is 40, 10 into 5 is 50. Now check it out if you want. 49 plus 56 is 105. 40 plus 50 is 90. Definitely this is in the ratio of 7:6. 15 into 7 is 105. 15 into 6 is 90. They are in the ratio 7:6, which is what they have asked in the question. Now final mixture ratio is 49 and 40 milk is totally 89. 56 and 50 milk is totally 106. Answer is 89:106. I believe that it is very clear for you. If it is given in terms of fraction or percentage, how to write the ratio equivalent. I believe it is very clear for you, sir.
Press the bell icon on the YouTube app and never miss another update.
Next, before moving on to the next question, some things that you need to know. Listen carefully, sir. There are few things that you need to know. This I already discussed in my DI class also. Data interpretation also, this I discussed because it was extremely useful there. Here also it is required. Now see here, sir. Suppose, let me give some values for A and B. Suppose A is 50. Just some examples I am taking so that I can explain you with numerical values. B is 40. Suppose your first question is what is A percentage of B? Suppose this is the first question. Second question is A is what percentage of B? Third question, B is what percentage of A? B is what percentage of A? Suppose let us take these three questions initially and then we will solve another one or two questions for the same logic. Now see here, sir, very simple logic. There are only two variables. One variable is A, which the value is given as 50. Another variable is B, where the value is given as 40. Now there are only two variables. What I will only say you is there is something written as off here, right? There is something written as off. Off is nothing but direct comparison. That is something which you need to remember. Off is nothing but direct comparison. Sir, what is the meaning of this direct comparison? Simple. What is A percentage of B? You don't need to take it as X and all those things and waste your time. Simple language. Whatever is coming after off, whatever the variable which is coming after off, that should come in the denominator. What is coming after off in the first question? B is coming after off in the first question. That B value should come in the denominator. Simple way of remembering. B value should come in the denominator. Then, sir, then what is the numerator? Numerator is nothing but directly write the other variable. That is the reason I wrote here. Off is nothing but a direct comparison. That means directly write the other variable in the numerator. Your numerator is nothing but the other variable A. Similarly, second question, what is coming after off? B is coming, and because off is given in the question, directly write the other variable in the numerator. Again, second question is A by B. A by B is nothing but 50 by 40. 50 by 40 is 5 by 4. 5 by 4 is nothing but 125 percentage, right? So that is something which I am not teaching you here. B is what percentage of A? After off, which variable is coming? A is coming. So A is coming, keep that A in the denominator. Direct, because it is off, directly write the other variable in the numerator. Other variable is B. So it is 40 by 50, 4 by 5. 4 by 5 is 80 percentage. Now this is when off is given in the question. Suppose for example, your question is A is what percentage? A is what percentage more than B? A is what percentage more than B? Now listen carefully, sir. Very interesting another learning from this question. Of what we learnt, of is nothing but direct comparison. Here I am getting than. Than is nothing but difference comparison. Simple, sir. Of is direct comparison. Than is difference comparison. Simple way of remembering. Of is nothing but direct comparison. Than is nothing but difference comparison. That means here also same thing. Whatever is coming after than should come in the denominator. Write that B in the denominator because B is coming after than. What should be numerator? Numerator you should not write directly the other variable because question is not given in terms of off. Question is given in terms of than. Than means a difference comparison. That means numerator should be the difference of A and B. Whichever is greater, write it first. So it is A minus B. I believe that the idea is clear, right? A minus B by B. So it is nothing but 10 divided by 40. 1 by 4 is 25%. Suppose if your question is B is what percentage less than A? B is what percentage less than A? Same logic. After than whatever is coming, put it in the denominator. Write A in the denominator. Than is nothing but difference comparison. Numerator should be the difference of A and B. Which is greater? A value is greater than B in the question. So numerator is A minus B. Simple 2 to 3 statements that you need to remember is whatever comes after of or whatever comes after than, please write it in the denominator. That is the first point. Second point is whenever it is of, numerator is direct comparison. Directly write the other variable which is not written. Whenever the question is given in terms of than, numerator will represent the difference comparison where it is greater number minus the smaller number. Now this is something which you need to know. How to use this key point in our problem solving. Now see here, sir. Two vessels contain mixture of milk and water. That means there are two vessels. Mixture of milk and water is present in both the vessels. Okay, that is what we understood. Milk and water mixture. So this is mixture 1. This is mixture 2. If I write like my previous question. Now in the next statement, in first mixture, milk is 31.25 percentage less than water. That means, let me write it here. They are saying that in the first mixture, milk is 31.25 percentage less than water. Less than water. That means, can I say that milk is 31.25 percentage? 31.25, first of all, for your information, it is 5 into 6.25 percentage. 6.25, I taught you in my fraction to percentages as 1 by 16. 5 into 1 by 16 is, it is 5 by 16. That means milk is 5 by 16 less than water. Milk is 5 by 16 less than water. Can I say like this, sir? Can I say that whatever is coming after than, water is coming after than, that should represent the denominator. That means the denominator is representing water parameter. Water parameter is 16. Water parameter is 16. Now, because it is than is nothing but difference comparison. Numerator represents the difference between milk and water. Difference between milk and water is 5 units. That means, can I say that water is 16 units. Water is 16 units and milk is less than water. So you can get it out. Sir, milk can be 16 minus 5 which is 11, or milk can be 16 plus 5 which is 21. There also difference is 5 only, but milk is less. Or in simple language, can I say, if you are getting confused with that kind of statement, milk is, denominator is water 16, milk is 16 less is nothing but from 16 there is a decrease of 5. From 16 if I decrease by 5, milk value will be 11. So milk is 11, water is 16. That is your mixture 1. See the second statement. And in mixture 2, the difference between quantity of milk and water is 11.11 percentage of total mixture. That means in mixture 2, the difference between quantity of milk and water, they are saying that the difference is 11.11 percentage of total mixture. 11.11 percentage is nothing but 1 by 9. The meaning of 1 by 9 is denominator, whatever is coming after of, that should come in the denominator. So total represents 9. Totally 9 liters of mixture is present. Of is direct comparison. That means numerator will represent the other parameter. Other parameter in this question is nothing but a difference between milk and water. That means milk and water difference should be how much? It should be 1. Can I say that total it should be 9, difference it should be 1, total it should be 9, difference it should be 1. That means, so milk will be 5, water will be 4. Then only the total is 9, 5 plus 4, and the difference of milk and water is 5 minus 4, 1. So milk is 5, water is 4. Some of the tricky questions, sir. I am believing that you are understanding all these methodologies. Now read the next statement again. The next statement is, if 10.5 liters of first mixture and 7.5 liters of second mixture is mixed, that means they are saying that 10.5 liters of first mixture and 7.5 liters of second mixture is mixed. Or in other words, can I say this statement as the mixture 1 and mixture 2 are mixed in the ratio of 10.5 liters is to 17.5 liters. 10.5 is 3.5 into 3. 17.5 is 3.5 into 5. That means in our previous question they were saying directly as both the mixtures are mixed in the ratio 3:5. Instead of saying like that directly, they are indirectly saying as if 10.5 liters of mixture 1 and 17.5 liters of mixture 2 is mixed. So you can convert it like this as the two mixtures, mixture 1 and mixture 2 are mixed in the ratio 3:5. Then find the ratio of milk and water in the new mixture. Now I already taught you how to find this kind of problem solving. Can I say that 11 plus 16 is totally 27? Let me write here, sir. 11 plus 16 is totally 27. 5 plus 4 is totally 9. So but 27 and 9, they are not equal, but they should make it, you should make it in the ratio of 3:5. First of all, make them as equal ratio. 27 and 9 should become equal, so make it as 27. 27 into 1 is 27. 9 into 3 is 27. Now 27 into 1 27. 9 into 3 is also 27. You made it equal ratio, but they are not asking you to make it equal. They are asking you to mix it in the ratio of 3:5. Multiply first one by 3, second one by 5. If I further simplify this ratio, 3 and 3 will cancel. That means this 27 you should multiply only with 1, or in other words 11:16 you should multiply with 1. It is 11:16. This 9 you should multiply only with 5, or this 5:4 you should multiply with 5. 5 into 5 is 25. 4 into 5 is 20. The resultant mixture is 11 plus 25 is 36, and then 16 plus 30, 20 is also 36. The new mixture is having the ratio of 36:36, which is 1:1. Very, very excellent questions being solved in the most easiest way possible. There is no other possibility, Aryan. Where will you have other possibility? 5/16. Milk is 5/16 less than. Milk is 5/16 less than water. Denominator is water. Water is 16. Milk should be 5 less than 16. That means the milk should be 11 only, right? 5:4. Which one you are asking for? The second one. There is no possibility for second one also to be other values. The difference should be 1 and the sum should be 9. Sum should be 9. If you solve simultaneous equation also, 2m is equal to 10, m is equal to 5, water is 4. This is the only case which is possible. Rajshekar, this is the fourth question. I am explaining same logic. Do not keep asking the same doubt. One last time I am explaining. I am telling that I want to make it in the ratio 3:5. Finally, I want to make it as 3:5 ratio. First make it as 1:1 ratio and then multiply by 3:5. Because 1:1:3:5 is 3:5 only, right? Fourth question I am explaining of similar model, Rajshekar. Please keep your ears open for each and every question. Please see the next question, sir. Please see the next question. The ratio. Now, in all the questions, whatever we have discussed till now, it was only of 2 containers or 2 vessels. Now we are taking a question where it is of 3 vessels. The ratio of milk to water in 3 containers of equal capacity. That means the capacity of all the three containers should be equal. So it is given as 3:2, 7:3 and 11:4 respectively. That means first container is 3:2, next is 7:3, next is 11:4. So 3 plus 2 is 5, 7 plus 3 is 10, 11 plus 4 is 15. But the question says equal capacity. 5, 10, 15, they are not equal. Make it as equal. The LCM of 5, 10, 15, it is nothing but 30. 5 into 6 is 30. These two values also multiply by 6. 10 into 3 is 30. These two values also multiply by 3. 15 into 2 is 30. 11 and 4 also multiply by 2. Rephrase. The question says the contents of three containers are mixed together. What is the ratio of milk and water after mixing? So it is 6 into 3:2, 18:12. 3 into 7:3, it is 21:9. 2 into 11:4, it is 22:8. If you want, check it out. 18 plus 12 is 20. 18 plus 12 is 30. 21 plus 9 is 30. 22 plus 8 is also 30. They are having equal quantity, which is actually given in the question. The resultant is 18 plus 21 plus 22. It is nothing but 61. 12 plus 8 is 20 plus 9 is 29. Answer is 61:29. Answer is 61:29. Two containers is what we have solved in the previous few questions. Now I am taking it for a 3 container. It really does not make any difference. Suppose, for example, see here. Suppose, same logic once again for your better understanding. Proportion of milk and water in 3 samples is 2:1, 3:2 and 5:3. So it is 2:1, 3:2, 5:3. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. 3, 5 and 8. I should take the LCM. LCM of 3, 5 and 8. LCM of 3, 5 and 8. It is nothing but equal to 3 into 5 into 8. Because I told you that LCM of co-prime numbers 3, 5 and 8 all are co-primes. HCF of 3, 5 and 8 is 1. LCM of co-prime numbers is product of their numbers. That means 3 should become 3 into 5 into 8. Multiply by 5 into 8. 5 should become 5 into 3 into 8. Multiply by 3 into 8. 8 should become 3 into 5 into 8. Multiply by 3 into 5. I believe you are understanding. That means 5 into 8 I am multiplying 40 for the first value. 2:1 is to 40. It is 80:40, right? It is 80:40. Similarly, 3:2, I should multiply with 3 into 8, 24. 24 into 3, it is 72. 24 into 2, it is 45. Check it out if you want. 80 plus 40 is 120. 72 plus 48 is 120. 75 plus 45 is also 120. I am making it equal. Now, the resultant is what they are asking. Find the ratio of water and milk in the mixture. 80 plus 72 plus of 75. It is 227. 40 plus 48 plus 45. It is 133. This is milk and water ratio. Question is asked for water and milk ratio. Reverse it. Milk and water, if it is 227 is to 133, water and milk should be reversed. It is 133 is to 227. This should be my answer. Please see the next question. Next question is also similar model, but the way they ask the question slightly differs, sir. That is where you should understand. That is exactly the reason you should understand how you need to take it forward. In 3 vessels, each of 39.6 liters capacity, that means all the three vessels are capacity of 39.6 liters. Now you will think that there is something that I need to do with this number called as 39.6 in this question, and unfortunately 39.6 is a decimal number, and if I use a decimal I will keep struggling in my simplifications. So you will think that it's a slightly difficult question. That is where the examiner will try to trap, giving this kind of questions in the exam. Simple common sense. Each of 39.6 liters capacity means all are equal ratio. Every vessel is having the same capacity. The ratio is equal. That is the meaning. I should make the ratio equal. That is what I want. I am nowhere concerned about this number called as 39.6. Let this 39.6 be any other number. Suppose instead of 39.6, if they give some number in the examination paper as 52.5714286714 liters, I will not even bother about that number. It is a junk value for me. What you should understand is it's an equal ratio question. Simple. Once you understand that, problem becomes very easy. Mixture of milk and water is filled. The ratio of milk and water are 3, 1, 2, 3. 4 into 5 is 20. 20 into 7 is 140. That means 4 should become 4 into 5 into 7. Multiply by 5 into 7. 5 should become 4 into 5 into 7. Multiply by 4 into 7. 7 should become 4 into 5 into 7. Multiply by 4 into 5. 3 is to 1 is multiplied with 35. So this becomes 3 into 35, 1 into 35. 2 is to 3 is multiplied with 4 into 7, 28. So 2 into 28 is 56. 2 into 28 is 56. 3 into 28 is 84. 4 is to 3 is multiplied with 20. 4 into 5 is 20. 4 into 20 is 80. 3 into 20 is 60. Check it out. They are of equal ratio. 105 is to 35 is 140. Plus 35 is 140 in fact. 56 plus 84 is 140. 80 plus 60 is 140. Sir, should I not convert it back to 39.6? No, it is not required. The meaning of that statement is that they are saying that all should be equal. Simple. Don't complicate, sir. The final ratio is 105 plus 56 plus 80. It is 241. 35 plus 84 plus 60. It is 179. This should be my final answer. Now please see the next question. If you remember, in our 2 vessels or 2 mixtures problems which we solved 15-20 minutes before, the ratio were mixed in some ratio other than the equal ratio. Now what if it is 3 vessels or 3 containers mixed in some other ratio? What we solved the previous question is 3 vessels are mixed in same ratio. 3 vessels are mixed in same ratio in my previous question. What if they are mixed in different ratio? It really does not make any difference. I already taught you for 2 vessels. Apply the same logic once again here. That means, please see this question, sir. 3 containers have their volumes in the ratio 3:4:5. That means I should mix the 3 mixtures in the ratio 3:4:5 later on. That I will take care of it later, right? That I will take care of it later. Now see here. The next statement says they are full of mixtures of milk and water. That means milk and water is what is present in all the 3 containers. The mixture contains milk and water in the ratio of 4:1, 3:1 and 5:2, right? This is what the ratio is given. The contents of all these 3 containers are poured into a 4th container and they are mixed in the ratio 3:4:5, which is given in the first statement. Find the ratio of milk and water in the 4th container. Very easy, sir. I already solved it for 2 containers. This is another extra 1 container. It really does not make any difference. 4 plus 1 totally 5 liters is present in first container. 3 plus 1 totally 4 is present in second container. 4, 5 plus 2 totally 7 is present in third container. Can I say that? First, they are not in equal ratio. First of all, make it equal. After making it equal, multiply 3 is to 4 is to 5 for that equal ratio, so that the final will become 3 is to 4 is to 5. Why? Because 1 is to 1 is to 1 multiplied with 3 is to 4 is to 5 is nothing but equal to 3 is to 4 is to 5 itself. That means first make it as 1 is to 1 is to 1. 5, 4 and 7, you should make it as 1 is to 1 is to 1. LCM is 5 into 4 into 7, right? LCM is 5 into 4 into 7. That means 5 should be made as 5 into 4 into 7. Multiply by 4 into 7. Multiply this value by 4 into 7. 4 should be made as 4 into 7, 5 into 4 into 7. Multiply 3 is to 1 by 5 into 7. I believe you are understanding. 7 should be made as 5 into 4 into 7. Multiply this ratio with 5 into 4. But this, when I multiply this with these values, I will get it as equal ratio. But question says they should not be equal. They should be mixed in the ratio 3 is to 4 is to 5. So multiply first value by 3, second value by 4, third value by 5. Now if you observe carefully, in all the three values, 4 is there. Cancel that 4 ratio in each of the case. That means 4 is to 1. I am multiplying with 21. What is that 21? 7 into 3 is 21 itself. 4 into 21 is nothing but 84. 1 into 21 is nothing but 21. Next, 3 is to 1. I am multiplying with 7 into 5, 35. 3 into 35 is 105. 1 into 35 is 35. Next, 5 is to 2. I am multiplying with 5 into 5, 25. 25 into 5 is 125, and then 2 into 25 is 50. Resultant in the fourth container is 84 plus 105 plus 125. It is 314. 21 plus 35 plus 50. It is 106, which can be further divided by 2, which is nothing but 157 is to 53. Answer for this question is 157 is to 53. There is no difference, sir. It is only until you understand you will struggle. Once you understand, you will start loving it. Until you understand, definitely you are going to struggle. But after you understand it, I am sure that you will start loving the concept, sir. Another question for your better understanding. These all the questions I want to repeat it to 1 or 2 or 3 questions, similar model, so that my students will not face any problem. See here, 3 containers A, B, C are having mixture of milk and water in the ratio 1:5, 3:5 and 5:7 respectively. That means it is given as 1 is to 5, 3 is to 5, 5 is to 7. That means first mixture is 1 plus 5, 6, second is 3 plus 5, 8, third is 5 plus 7, 12. LCM, first of all, okay, let me read the next statement first of all. If the capacities of 3 containers are in the ratio 5 is to 4 is to 5, they don't want you to make it in the ratio 1 is to 1 is to 1 and stop it. They actually want you to mix it in the ratio 5 is to 4 is to 5. So first make it as 1 is to 1 is to 1, multiply with this 5 is to 4 is to 5, so that finally it will be 5 is to 4 is to 5. Find the ratio of milk and water if all the 3 mixtures are if the mixture of all 3 containers are mixed together. Now see here, first of all let us make 1 is to 1 is to 1. It is not in 1 is to 1 is to 1 as of now. It is in the ratio 6 is to 8 is to 12. 6 is to 8 is to 12 should be made as 1 is to 1 is to 1. That means, can I say that LCM of 6, 8 and 12 is, it is 24, right? It is 24. First make it as 24. 6 should become 24. Multiply by 4. 8 should become 24. Multiply by 3. 12 should become 24. Multiply by 2. Now, I made it equal at this point of a time. It is 24 is to 24 is to 24 as of now, which is equal ratio. But I don't want it equal. I want it to be in the ratio 5:4:5. Multiply first one by 5, second one by 4, third one by 5. Simple logic, and no ratio can cancel. In fact, this can cancel out if you want to cancel. 2 into 1, 2 into 2, 2 into 2. That means 1:5 should be multiplied with 2 into 5, 10. So it becomes 10:50, right? It becomes 10:50. Next, 3:5 should be multiplied with 3 into 2, which is 6. 3 into 6 is 18. 5 into 6 is 30. Next, 5:7 should be multiplied with only 5. So it is 5 into 5, 25. 7 into 5, 35. Final ratio is 10 plus 18, 28. 28 plus 25 is 53. 50 plus 30, 80. 80 plus 35 is, it is 115, right? 80 plus 35 is 115. Answer is 53:115. People who think that they want to sleep on a Saturday morning missing this class, let them sleep. Let them do whatever they wish to. I really will not care. I will not even fight with my finance team with now onwards, sir. I had fought enough for your good, but I know how to take care or how to cut short you people from now onwards. I will take care of my students for how much ever extent it needs to be taken care of. I will not go beyond my limits from now onwards. There are times where I prepared so many beautiful questions till midnight, 2 o'clock, 3 o'clock, when I had a class of 6:15 a.m. I slept at 2 o'clock so many times. Yes, in fact, yesterday midnight also I slept at 2 o'clock only because I was seeing a cricket match. But this is not the scenario I am saying right now. I am saying a scenario where I slept at 2 o'clock, 2:45, 2:30 so many times to prepare some excellent questions for my students. But I am understanding that is okay. Students are students only. They will take care of themselves. They know how to respond when it is only required to be responded. That's okay. Where second ratio is 3:1, Arvind? It is given in the question as 3:5, right? From where are you thinking it as 3:1? Please see the next question. There are 3 mixtures containing milk and water. That is the first statement. Okay. Milk and water is present. 3 mixtures. So, question says, in first mixture, milk is 37.5% of total mixture. That means, let me write it on the right side of the screen. In my first mixture, milk is 37.5%. 37.5 is 3/8. 37.5% of total mixture. That means whatever comes after of should be there in the denominator. Total is 8 liters in the first mixture. Of is direct comparison. The other parameter is milk. Milk is nothing but the numerator. That means total is 8 liters. Total is 8 liters. Out of that, milk is 3 liters. That means the remaining 5 should be water only, right? Because there are only 2 parameters, milk and water. The remaining parameter should be water only. Remaining 5 should be water. Next, in the second mixture, milk is 28.56% less than water. That means in my second mixture, mixture 2, I told you that 28.5714% is 1/7. That means milk is 2/7, sir, not 1/7. Milk is 2/7 less than water. Milk is 2/7 less than water. That means after than whatever is coming, that should be there in the denominator. Water is 7. So put water value 7 for second mixture and numerator is 2. Whenever it is than is difference comparison. Difference is 2, or in simple language, milk is 2 by 7 less than water. That means if water is 7, milk is 2 units less than water. 2 units less than water means milk should be 5 units. So total of 7 and 5, it is nothing but 12 in the second mixture. And in the third mixture, the ratio of milk and water is 5:4. No headache in the third mixture. Directly they have given as 5:4. 5 plus 4 is 9. Now, listen carefully, sir. Listen carefully. Can I say that if 12.4 liters of first mixture, 15.5 liters of second mixture, and 9.3 liters of third mixture are mixed together, or in other words, I can say that all the three mixtures, whatever I wrote in ratio format right now, they are mixed in the ratio of 12.4 liters is to 9.3 liters, sorry, 15.5 liters is the second mixture, right? 15.5 liters is to 9.3 liters. The three mixtures are finally mixed in the ratio 12.4 is to 15.5 is to 9.3. 12.4 is nothing but 12.4 is nothing but it is 4 times of 3.1. 15.5 is 5 times of 3.1. 9.3 is 3 times of 3.1. That means they all are mixed in the ratio 4:5:3. Instead of giving directly, they are giving like that at 12.4, 15.5 and 9.3, so that you will get confused. So if all these three mixtures are mixed in the ratio 4:5:3, find the ratio of milk and water in the new mixture. Now see here, sir. Forget about this 4:5:3, that we will do it later on. First let us make equal ratio. 8, 12 and 9. 8, 12 and 9. They are not equal. 8, 12 and 9, they are not equal. First make it as equal. LCM of 8, 12 and 9 is 72. 8 should become 72. Multiply by 9. 12 should become 72. Multiply by 6. 9 should become 72. Multiply by 8. 9 into 8 is only 72. Now when I multiply with 9, 6 and 8, they are becoming equal ratio. But I don't want it to be equal according to the question. They should be in the ratio 4:5:3. Multiply this by 4, multiply this by 5, multiply this by 3. Simple logic, sir. If I can further simplify this ratio, this can be further simplified as 3 into 1, 3 into 2, 3 into 3, right? 3 into 3. Now again, can I again further simplify? This is 2 into 1. 2 into 2, 2 into 4. That means this is nothing but first value. I am writing here in the middle of the screen. First value of 3:5. You should multiply with which number? You should multiply with 3 into 2, 6. 3 into 6 is 18. 5 into 6 is 90. Sorry, 5 into 6 is 30. Next, this 2 is also cancelled here. Only thing left to be multiplied is with 5. 5 into 5 is 25. 7 into 5 is 35. Next, 4 is written here. 3 is cancelled. Only thing you should multiply is with 4. 5 into 4 is 20. 4 into 4 is 16. Final mixture ratio is 18 plus 25 plus 20. It is nothing but 63. 30 plus 35 is 65. 65 plus 16 is 81. 63 is to 81 can be further simplified as 9 into 7. 9 into 9. Final answer is 7:9.
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our revolutionary app for free.